Good morning, everyone. We were discussing about network layer. Today, in the video lecture, we will learn about network address translator. So, today's topic is network address translator, or we call it as NAT. So, this is the last topic under module number 3. So, we'll see what is this network address translator and how we can achieve this address translator using different methods. We have seen in case of classless addressing, whenever any organization require a block of addresses, usually ICANN will distribute the address to ISP, and in turn ISP is going to distribute it to the required organization or to the customer. But as the organization grows, so it is going to create few problems. Let me take a case wherein we'll take an organization. Let us take a small organization for which it requires a small range of addresses. So ISP is going to grant those addresses to the organization. After some year or after some time, when the business grows, then it might require a large amount of addresses, so it might require additional addresses for the organization. During that time, ISP cannot grant the address, because as we learned in previous lectures, whenever ISP grants the addresses, a block of addresses, so it sees to it that the addresses are continuous. Out of the three condition, one condition is that the addresses whatever is assigned to a particular organization, it is continuous. So according to that, when the new address is required, when the additional addresses is required, ISP may not able to give that continuous address, because the before address or the after address might have been already allocated to the other users, because the organization in the previous case or some year back wanted only limited addresses. So what ISP will do, that will be assigned to that particular organization, so the immediate next addresses will be allocated to the some other organization. So in after some years, so when this crime comes into picture, so the ISP cannot give a continuous address. So this is the problem associated with the class less addressing. So to overcome these kind of issues, so the network address translator has come into picture. So the new method wherein uh, addresses for the organization can be still assigned by using a method called network address translator. Let us take an example. uh, Assume there is a small business organization with some around 20 computers, and at one particular instant of time, out of 20, 4 or 5 will be accessing the internet. So let us assume only 5 out of 25 will be using the internet at any given instant of time, and rest of the computers will be busy doing some tasks which does not require internet. So it might be some internal task will be performed. So what organization can do is, in this case it can take some addresses are private addresses and few addresses as universal addresses. So out of 20, so 15 addresses it can take it as a private addresses, and 5 addresses it can take it as universal addresses for communication. So whatever the private address is said, so that will be used within the organization, and whenever it want to communicate with the external world, then it will use the universal address assigned by the ISP. So, network address translator is a method wherein there will be two types of addresses. One is private address, one more is universal address. The private address will be within the organization, so this address will not be visible to the outside world. So whenever organization want to communicate with external world, it will use the universal address assigned by the ISP. So as you can see here, there are three sets of addresses which has been given as private addresses. So this is fixed, so from the outside the organization it cannot be seen. So these addresses are unique inside the organization, but they are not unique globally. So any organization can take the addresses given in this particular range. So three sets we have. The first set which starts with 10.0.0.0 to 10.255.255.255, that is 2 to the power of 24 addresses. Second set starts with 172.16.0.0 to 172.31.255.255, that is 2 to the power of 20 addresses. And the last set is 192.168.0.0 to 192.168.255.255, that is 2 to the power of 16 addresses. So depending upon the requirement, any addresses among this can be used inside any organization as a private addresses, and no router will forward a packet that has one of these addresses as the destination address. So this addresses whatever is given in these three sets will not be the destination address in any case. So any router is not going to transfer the data or the packet to this particular address. This is inside the organization. As I said, it is only visible inside the organization. For the outside world, it is not visible. So with this, we'll see how this actually works. So we can see here we have two diagram. One is the implementation part, one more is translation part. So a technology that can provide the mapping between the private address as well as universal address is called NAT implementation, and at the same time support it is going to support virtual private network. It is going to support virtual private network. The site might have only one connection to global internet. As you can see here, only one address globally through the NAT router. So through NAT router, we'll have only one address that has been connected to internet, and within the organization there are multiple addresses. You can see 172.18.3.1, 172.18.3.2, 172.18.3.20, so on. So any number of addresses within the given range can be assigned within the organization as private addresses. So as you can see here, whatever the address you can see here, this is the network address of this private network. So if any external word want to send a message to any of this system or the computer, then the destination address will be this particular address. So this address has to be mentioned as destination address, and this NAT router is going to map to the any system inside this based on the entry in the table. So if any computer here or any host want to communicate with the external world, then first it has to send a data to NAT router. That is going to change the address of the source to this particular address, and then it is going to transfer it to, or it is going to send it through the destination. You can see the address translation here. So let us take one case wherein the host once with the address 172.18.3.1 want to send a data to a host which is somewhere outside this private network. So it is going to generate, or it once the packet is done, so it is going to add the source address, that is nothing but 192.18.3.1 as a source address, and it will be transmitted. Once this packet reaches the NAT router, then the NAT router is going to change the address to the address of the particular router or the NAT network. So that address is 200.24.5.8. So you can see whatever the address was there, that has been changed to the network address or NAT address of this particular private network, and it will be sent. So once we get, or once the replies comes from the destination to the source, then the external word can see only this as the source address with this as a destination address. This is going to send the data to the this private network. At once again at the NAT router, once it receives this packet, then it is going to change that address to the previous one, that is 172.18.3.1. That address will be added and the packet will be moved to the corresponding destination. Now, so the next question is, there are multiple or more than 100 systems will be there within a private network. How the NAT will come to know the destination address for the incoming frame or a packet when more than 10 or thousands of private addresses are present? So this issues will be solved using something called transition table. So using something called transition table, this issue is solved. So we'll see what is that transition table. There are multiple ways we can do this. The first one is using one IP address. That is, we'll take a case wherein there is one IP address for this NAT and you have a private network here. So whenever the device want to send a data to the external world, so it is going to add its address, that is 172.18.3.1, that is a private address, and it will be sent. So what NAT router will do, it is going to change that to the address of the NAT, that is 25.8.2.10. Once it does so, it is going to enter that in a table which is called as transition table. So one IP address will be noted here. So where exactly the data has been originated, to that which address has been given allotted, that will be taken or that will be noted in transition table. And once the destination sends the message reply to the whatever the packet has been sent, that is from the destination to source, now it is going to add the destination address as 25.8.2.10. So it will come to this NAT router. So this address, it will see what is the corresponding mapping address. So the corresponding mapping address is 172.18.3.1. So to that it is going to send the packet, it is going to forward that packet. So this is the case wherein we have only one IP address, that is at one instant of time we can communicate with only one device. The same can be implemented using pool of IP addresses. Here we have used only one IP address, instead we can use pool of IP address, that is more than one IP addresses. The use of only one global address by NAT router will allow only one private host to access the given external host. So only one private, as I said, one private host can access to the external host. So to remove this restriction, what NAT can do is, instead of using one address, that is one address here, NAT address, it can go for multiple addresses. So it can, for example, it can go with four addresses. So in that particular case, when the addresses are NAT router uses four addresses, then four private networks, so four networks inside this private network can communicate with the different external host at that same time, at the same time. So four devices can communicate, because now I have got four IP addresses. So I'll have, this is only one, but when I go with pool of IP addresses, I'll have four four IP addresses. So one is this. Similarly, when one more private network want to communicate, so you'll have one more address. Similarly, the third one, and similarly the fourth one. So if I have four IP addresses, then four private devices can communicate with the four external devices. But the disadvantage is, so how many addresses you take, how many IP addresses you take, only those many connection can be established at one given instant of time. So this can be avoided, or this disadvantage can be overcome by the one more method, the third method, in which both IP address as well as the port address as well as the IP addresses can be used for network address translator. So the first one is only one IP address, second one is pool of IP addresses, and the third one is both IP address as well as port address. So using both IP addresses and port numbers, to allow many to many relationship between private network host and external server programs, we need more information in the transition table. So if we are able to maintain the multiple data or more data related to one particular network, then we can go with multiple uh, relationship. So if the transition table has 5 columns instead of only 2, that is we had only private address, port, as well as the external address. In this case we are going to maintain 5 different data. That is, one is private address, second one is private port, next one is external address, next one is external port, and the last one is transport protocol. So what is the address of the private address of the host, where it has been connected, there is a port address, followed by to which external address has been mapped to the given private address, and which is the external port address given to that, and which is the protocol running in that. See, all these 5 data will be maintained. So using this, you can go for multiple data transfer at same instant of time. So you will not have any restriction on moving the data from the private network to the external world. So this will be the end of module number 3. So uh, in the next coming module we'll be discussing about the different protocols used in network layer. So in this particular chapter we are seeing the basics of network layers, like addressing scheme, what are the services provided by network layer, as well as how the addresses will be allocated to the organization and how it can be increased. All those things we have seen in this particular module. So the module number 4 will be the continuation of module number 3. So wherein we are going to learn different protocols used by network layer for communication. So before I end up for module number 3, I need to, or I wish to give two assignments. One assignment question is, first question is, you need to explain the working of NAT with the help of address translator table, and the second one is difference between the datagram network as well as virtual circuit network. So I repeat, you'll be given, or I'm giving you two questions as assignment. First question is, with a neat diagram explain how NAT help in address translation. So you need to explain what is NAT, how it can be achieved using only one IP address, pool of IP addresses, as well as using both IP address and port address. Question number 2 is to differentiate between datagram network and virtual circuit network, which we are dealt in previous videos. So you explain, you have to tell what is datagram network as well as virtual circuit network, and what is the difference between those two network. So any doubts related to this, you can get back to me. uh, all the best. Thank you.